Hello everybody, this is Mr. Ray with another math lesson while we're at our homes. Um, so in this lesson we're basically going to be finishing off Unit 2 from the course, um, and there is an assignment directly from this lesson. So there's not a whole lot to the lesson. It's kind of putting some things together that we've been doing this unit and last unit as well. And I'll also talk about the assignment. Hopefully it's pretty straightforward. So today's lesson is called converting between quadratic forms. So I'm going to go down to this, very, very proud of this diagram. I created it myself. So you can see it's a big triangle. Each of the four corners of the triangle is a different quadratic form. In other words, a different way we can write the equation. So when we first started with quadratics, we talked about this form, which we now know as standard form, y equals ax squared plus bx plus c. This one you can see very easily. It's got no brackets. Okay, it's got an x squared term. It has to, otherwise it's not a quadratic. Okay. Then the next form we learned was vertex form. Um, this is what we used when we started with y equals x squared, and uh, we translated, we stretched, compressed, we did different transformations to create a new parabola that might have a different shape, probably in a different position. But this was vertex form, y equals a bracket x minus h squared plus k, and we quickly learned that h comma k was the vertex, and that's why we call it vertex form. And then the last form we did, which was last week, factored form, looks like this. It's basically taking, putting a quadratic into its factors, which we did a lot of factoring in Unit 1, and you're going to have to recall those skills for this assignment. So hopefully you remember. So you know that this is factored form because it's got two single x term factors, and remember the r and the s are actually the x-intercepts. Okay, so when we put these three forms at the corners of this triangle, what we're going to be doing in this assignment is converting between the three forms. For example, I could give you vertex form, and you should be able to create both this standard form and factored form. Or I could give you factored form, and you would create the standard form and the vertex form. Okay, or standard form, and you create vertex form and factored form. So that's basically what this lesson and this assignment are all about. Now, in terms of the processes to go from one form to the other, you can see these arrows on the side. These are the actual processes, the strategies we use to go from one to another. For example, if I started with standard form and I wanted to create vertex form, I would do completing the square, and that's what we just did last lesson. So we did a whole lesson on going from here to here. So that's recalling that lesson. If I gave it to you in vertex form and I wanted you to create standard form, you would just expand this. Okay, and I'll show you an example of that later on. But you basically take the x minus h, you square it, and then you multiply by a, and then you add k, and you come up with a standard form version. Okay, so that's expanding, going from vertex form to standard form. If I'm looking going between standard form and factored form, well, standard form to factored form is basically what we did in Unit 1. This is factoring. Okay, so you're going to have to remember, how do I start with a quadratic in standard form? How do I factor it? So you may have to look at some of the lessons from Unit 1 and remind yourself how to do that. Okay. If you need help with that, I'll be online Tuesday and Thursday this week. So make sure if you have questions that you get on and ask them before the assignments due, or you can talk to your friends as well. Okay. So factoring, this is a Unit 1 process, just like expanding was. If I want to go from factored form to standard form, I expand. I just do my FOIL here and then multiply everything by whatever a happens to be. Now the interesting thing is that's kind of four directions on this triangle. if I want to go from vertex, between vertex and standard form, sorry, vertex and factored form, see this line here, it's got 2 dashes, that means you can't go directly. So what do? If I want to, say I start with vertex form and I want to create the factored form, well, what it means is I have to go around the outside of the triangle. So first I have to expand vertex form to standard form, and then I factor this into factored form. Okay, if I want to go the other way, factored form to vertex, I expand to standard form, and then I complete the square. Okay, so uh, this is the only place where we can't go directly between two forms. Okay, now if I look at, here is the second page of this lesson, is the actual assignment. So you can see it says quadratic forms assignment, show all conversion work on a separate page to be submitted for marking. So what you're going to do is each of these 12 quadratic equations or relations, I give you one of the 3 forms. The first 4 are in standard form, the next 4 are in vertex form, and the last 4 are in factored form. So your job will be to take each of these and fill in the other squares based on looking at, well, how do we go from one form to the other? We have to know how to expand, we have to know how to factor, and we have to know how to complete the square. Okay. All right, so I'm going to do an example of each for you. Not so much one of these that's already here, although I am going to do this first one. So here's a freebie, because I always get students going, well, how do I change this to vertex form? How do I change it to factored form? Well, if it looks like this, well, you could say, well, I could just write that as y equals x minus 0 squared plus 0. Okay, and that looks more like vertex form, but subtracting 0 and adding 0 really doesn't add anything to it. If I just, if I just wrote it as y equals x squared, that is in vertex form. Okay, so, and you'll see maybe the second one is like that too. Okay, now factored form. Factored form is a little bit different. How do I write x squared as a set of factors? Well, I could just write it with x squared is really just x times x. So I could say, well, I could write that as x times x, or to make it look more like factors if you wanted, you could say, well, that's just x plus 0 times x plus 0. But really, it's, I could just write it as x times x. So that would be the factored form of x squared. So your job will be to fill in the rest of this table. Make sure you put your name here. I'm a genius. Hopefully you are. So what I'm going to do now is I've picked out examples of, first of all, giving you a standard form equation and how to get the vertex form, how to get the factored form. Then I'll have examples on these other two and how do you get the other 2 forms. So let's just go through that right now. So, all right, so I've turned this page sideways just so I can fit it, but I've got basically, here's my first example, and if hopefully you realize what form is this? This is already in factored form. Okay, and if I look at this one, well, how do you know what form that is? Well, it's no brackets, tells you this is standard. And this one is vertex form. Okay, so for this one here, that would be an example of one of these questions where I give it to you, I give it to you in factored form already, and you have to create the other 2 forms from it. So let's see how we do that. Okay, so if you remember, if I already have it in factored form, I really don't have a choice as to what I do first, because I can't go get the vertex form directly. So what I'm going to have to do in this case, if I'm given factored form, first I create standard form, and then from standard form I create the vertex form. Okay, so here's my example. So if I start working on that, this is basically, I do my FOIL. here. So I'm going to get x squared plus 2x minus 6x minus 12. Remember, you're just doing FOIL, okay? And we can simplify those two and get y equals x squared minus 4x minus 12. Okay, so right there we've just created our standard form. Didn't take much work. But now we take the standard form and we're going to create vertex form. So this is where we complete the square starting from here. So this one's not too bad. We just put the first two terms in brackets. And then we determine what's that magical third term that makes this a perfect square trinomial. We take half, just let me get started here. We take half of the negative 4, which is negative 2. Square negative 2, we get positive 4. So that's what we need. We have to offset that by subtracting 4. And now this is the take out the garbage step. You move that outside the bracket because we only want the perfect square trinomial inside the bracket. Okay, and when we take it out, don't forget, you always have to see if there's something in front, like a common factor you had here. In this case, there isn't. It's just a 1. So 1 times negative 4 is just negative 4. So we can bring it out like that. And then we're almost done. We turn, so there's no a value. We don't have to worry about that. And then it's going to be x plus or minus a term squared. And we can combine these two right away. That's minus 16. And then remember, in order to get that term, it's quite simple. It's just half of the coefficient of x. So half of negative 4 is negative 2. And there you go. You've got your vertex form. So what you would need to do if this was a question, you'd need to show me this work on a separate page, and then you just plug these new other forms back onto your main page here, so you would fill in what we did over here. Okay. All right. Now, I always get asked, well, maybe I don't always get asked, but I always suggest, well, how do you know you're right? And there's two ways of doing it. One is just to do the work again, but if you made a mistake the first time, you're likely to make it again. So what I would suggest is using Desmos. So what you can do is you can actually put in multiple equations to graph and see all three graphs at the same time. So why not put this as your first graph, the factored form, put this equation for your second graph, standard form, and put this equation for your third graph. And if you're right, you should see all three parabolas exactly the same. In fact, you'll only see one line because they are all the same. Okay. Now, if it's off by a little bit, well, that's not good. Close doesn't really count here. So what you have to do is, if it's off by a bit, see what you need to do to create. Now, you always know which one is right because it's the one that was given. So if these two graphs aren't the same as this, well, these two will be wrong, not this one. So you have to figure out, well, how did I mess this one up? Because its graph is not the same as that. So that's the best way of checking your work. Okay, here's the next example where you have standard form given, and we need to create factored form and vertex form. Now, in this case, if I give you standard form, well, you have a choice. You could either complete the square and get vertex form first, and then do the factoring to get factored form, or you could get factored form first and vertex form. So in this case, it doesn't really matter what you do first. Let's see, let's do factored form to get that done. So let me just write the equation again. Now, remember, when we factor, the first thing we always try to do is take out a common factor. And in this case, it works out great because every one of these I can divide by 3. So when I factor out the 3 as a common factor, it turns it turns from a complex trinomial into a simple trinomial. So that's always a good thing. So now I want to try to factor this. I need two numbers that multiply to -4 and add to +3. Now, did I do that right? Okay, yeah, so that does work. I need two numbers that multiply to -4 and add to +3, so that would be +4 and -1. Okay, now you can do it with the t-chart like we learned in Unit 1, or you could do it in your head, but it's going to be x plus 4, x minus 1. And you can always check this. If you expand that, you will get that. Okay, so now you can see this is in factored form. So we've accomplished our first goal. Okay, now the second, we've got standard and factored. Now we want vertex. Now I'm not going to start from here, because if you remember, you know, I've started with standard form in this case, and I just created factor form. Well, factor form's not going to help me get vertex form. I can't go there, but I can go back to the original standard form equation and complete the square to get vertex form. So that's what I'm going to do. I'm going to rewrite the original equation, and we put brackets around the first two terms when we're completing the square. Then we factor out the whatever the a value is from both of these terms. So we get x squared plus 3x minus 12. Now, this is where we complete the square. This is the complete the square part. I need the third term in here that makes this a perfect square trinomial. Now this is a little trickier because we take half of 3. Half of 3 is 3 halves, or 1.5. And if I square 1.5, I get 2.25. So that's the number I need to make that a perfect square. But again, I have to subtract it to keep it equal. And then we put the minus 12 there as before. Okay, now here's where we take the garbage out. I want to take that term outside the brackets. This time I have to multiply it by 3 first. Okay, so I'll just leave in the first 3 terms. There's my perfect square trinomial. Now when I take this outside, it's 3 times -2.25, so that's -6.75. And now, last step, first thing we do is we change this into a perfect square, into a binomial squared, and we add these two together to get our term there. And remember that it's not that tricky. We always know that it's going to be x, whatever that is, whatever variable's there, and it's going to be half of the +3. So that's half of 3, which is plus 3 halves, or plus, you could say, 1.5. Okay, and there we have our vertex form. Okay, last type of case was where we start with a vertex form and we want to create the other two forms. So again, starting with vertex form, we have no option. We can't go and get factored form directly. We have to go create the standard form, and then from the standard form create the factored form. So now this is where you have to be careful. So x plus 5 squared is not just x squared plus 25. Don't fall for that. X plus 5 squared is x plus 5 times x plus 5. Okay, now you don't have to do this step, but it helps avoid that mistake. When you expand this, you get x squared plus 5x plus another 5x plus 25 minus 18. And now this is just combining the like terms. We got 2x terms and 2 constants. We get x squared plus 10x plus 7. And that is our standard form. Okay, so don't forget about how to expand that. Now, I did notice on the last assignment a lot of people were making mistakes on that first page when I gave a table. I gave some equations. I think all the equations were given in vertex form, and I asked you, well, what's the y-intercept? Now, the y-intercept happens when x is 0. But a lot of people were confusing, saying, oh, the y-intercept is always that term at the end here. That's our c value. That's not the c value. That's the h value, sorry, the k value from your vertex. You can see when you convert to standard form, this would be your y-intercept. Okay, so I saw quite a few people get that wrong. They correctly said the vertex was -5, -18, but then they said, oh yeah, the y-intercept is also -18. That's not true because this is not in standard form, so this is not c. This is in standard form. There's your c, that's your y-intercept, okay? So that's just something to remember for future lessons. Okay, now that we've got standard form here, we want to create the factored form. So this is a simple trinomial, so we know if it does factor, it's going to look like this, and I need two numbers that go here and here that add to 7 and multiply to 10. So that would be +5 and +2. And very quickly get the factored form. So that's how you would do this assignment in these three examples. Given factored form, you do this. Given standard form, you do this. Given vertex form, you do this. Now, if we look back at this picture here, hopefully you remember when I taught you completing the square, I said this always works. I can always start with standard form and create vertex form. We know expanding always works. It's just multiplying things out. Okay, so going from factored form to standard form always works, and going between these two always works. Now, what might not work is sometimes we might get an equation in standard form that is not factorable into this. Okay, and that does happen a fair bit. Now, hopefully you're paying attention to this video lesson, because here's a big hint for the assignment. In this page here, okay, there may be one of these. At the very most, there's one of these that's not factorable. There might be, they might all be factorable, or there might be one that's not factorable, but there's definitely not more than one that's not factorable. So when you're doing this and you get stuck more than once, don't just tell me that's not factorable, okay? Because there may be one that's not factorable, but there's not more than one, okay? So that assignment will be due, let's say Friday at midnight this week. Let's have you guys not have any work for the weekend. I will be posting another lesson, maybe two this week, but the assignment that I'm giving you, this quadratic forms assignment, will be the only assignment this week. So again, when you hand it in, it's going to have this basically as a cover page with your final answers filled in, and then basically a bunch of pages that would say, okay, here's my question. You know, this might be number 1, this might be number 5, this might be number 7, and the work I did to get these answers. Okay, so again, please remember, we'll have online help, my office hours this week, Tuesday and Thursday. Just join in, and if you're getting stuck on something, I can help you through it. Okay? All right, have a good day, and we'll talk to you soon.